Welcome to my YouTube channel Mechanical Magic Mechanical Learning Tutorials. I Professor Mayur S. Modi. Today we will discussing with the powder metallurgy process which will be used to converting raw material into finished products. So let us start with the overview of the contents. Introduction to manufacturing, introduction to powder metallurgy. Powder metallurgy, a competitive process details, economics and design consideration, application, advantage and limitation of powder metallurgy. Introduction. Powder metallurgy is used for manufacturing products or articles from powdered metals by placing their powders in molds and by compacting the same using heavy compressive forces. Typical example of such articles or products are grinding wheels, filament wires, magnets, welding rods, tungsten carbide, cutting tools, self-lubricating bearings, electrical contacts and turbine blades having high temperature strength applications, which will be difficult by manufacturing of any other methods. So only feasibility with respect to the performance and the economic consideration, powder metallurgy process is the best process among all the manufacturing processes. The manufacturing of parts by powder metallurgy process involves manufacture of the powder, blending, compacting, sintering and a number of secondary operations such as sizing, coining, machining, plating and various heat treatment processes. The compressed articles are then heated to the temperature much below their melting points to bind the particles together and improve the strength and other properties of the materials. Few non-metallic materials can be added to the metallic powders to provide adequate bond or impart some of the needed properties. So in the case of powder metallurgy process, it will be the possibilities for combination of the metallic as well as non-metallic composition materials, so which will be enhancing the properties of the materials. The products made through this process are very costly on account of the high cost of the metal powders as well as of dye is being used. The powders of most all metals and a large quantity of the alloys and non-metals may be used. The application of the powder metallurgy process is economically feasible only for the mass productions. Parts made by powder metallurgy process exhibit properties which cannot be produced by any conventional manufacturing methods. Simple shape parts can be made to size with high precision without waste and comparatively or almost ready for the installation. So you can achieve the zero scrap in the production by the powder metallurgy process, which will be not possible for any other manufacturing process. So that will be having a major advantages of the powder metallurgy process. Here is the sum of the layout of the powder metallurgy process, or you can say the sum of the steps to follow for the powder metallurgy process. Number 1, to form metal powders with different process or methodologies. Then it will be going ahead for blending, mixing with some lubricants, additives, which will be increasing the binding characteristics. Third category, compacting process, or you can say the shaping process. So it will be having two types, cold compacting and hot compacting process. In case of cold compacting process, die compacting, cold isostatic presses, other methods like rolling, extrusion, explosive compacting process. In case of hot compacting, hot pressing, hot isostatic, extrusion process. After that shaping process, it will be further into the sintering process. In the sintering process, heated of your finished component up to the just below the melting point of the higher constituents, then it will be cooled down to the room temperatures. So it will be increasing the property of the materials. Then after, it will be going further into the secondary processes, like if some cutting, some drilling or some finishing operations are required, so that all operations it will be performing onto the sintered components, and then it will be going for the packing, or you can say the displacing, or you can say the raw material of the powder, it will be converting into finished powder metallurgy components. Powder metallurgy processes. First, formation of metallic powders, mixing or blending of the metallic powders in required proportions, compressing and compacting of the powders into the desired shapes and size in form of the articles, sintering the compacted articles in a controlled furnace atmosphere, subjected to the sinter articles to the secondary processing if needed. So if you are controlling all the process of the formation of the metallic powder, mixing, blending and proper contacting and sintering, so there is no need to performing the secondary operation. So you may save your money for the sintering process. Production of metal powders. So metallic powders processing different properties can be produced easily. The most of the commonly used powders are copper based and iron based materials, but the titanium, chromium, nickel and stainless steel metal powders are also used. In the majority of the powders, the size of the particles varies from the several microns to 0.5 mm. The most common particle size of the powders fall into a range of 10 to 40 microns. The chemical and the physical property of the metals depends upon the size and shape of the powder particles. There are various methods of manufacturing of the powders. Let's see the methodologies to form the powder. First, atomization process, chemical reduction process, electrolytic process, crushing process, milling process, condensation of the metal vapors. Starting with the first, atomization process. So in this process, the molten metal is forced through an orifice, and as it emerges, a high pressure stream of gas or liquid impinges on it, causing it to atomize into the fine particles. So as shown from the figure, the inert gas is then employed in order to improve the purity of the powder. It is used mostly for the low melting point metals such as tin, zinc, lead, aluminium, cadmium, etc. because of the corrosive action of the metals on the orifice at the high temperatures. So alloy powders are also produced by these methods. Chemical reduction process. The compounds of the metal such as iron oxides are reduced with carbon monoxide or hydrogen at temperature below the melting point of the metals in an atmosphere controlled furnace. The reduced product is then crushed and ground. Iron powder is produced in this way. So let's see the sum of the chemical reactions. Fe3O4 plus 4 carbon, that is equal to 3Fe plus 4 carbon monoxide. So further it will be reduced. Fe3O4 plus 4CO, that is equal to F3Fe plus 4CO2. Copper powder is also produced by the same procedure by heating the copper oxide in the stream of the hydrogens. So copper react with the hydrogen, so Cu2 plus H2, it converts into 2Cu plus H2O. So the powder of vanadium, molybdenum, nickel and CO can be easily produced or manufactured by reduction process because it is a convenient, economical and flexible techniques, and perhaps the largest volume of the metallurgy powder is made by the process of the oxide reduction process. Electrolytic process. The electrolytic process is quite similar to the electroplating and is principally employed for production of the extremely pure powder of the copper and irons. For making copper powders, copper plates are placed as anodes in a tank of electrolyte, whereas aluminum plates are placed into the electrolyte to act as a cathode. After a definite time period, the cathode plates are taken out from the tank, rinsed to remove the electrolyte, and then dried. The copper deposited onto the cathode plates is then scraped off and pulverized to produce a copper powder of desired grain size. So now you can see some of the mechanism of electrolytic systems. So anode, cathode and battery, and in between that electrolytic tank. So positive and negative ions, it will be transferring from anode to cathode. Crushing process. So the crushing process requires equipment such as stamps, crusher or gyratory crushers. Various ferrous, non-ferrous alloys can be heat treated in order to obtain a sufficient brittle material which can be easily crushed into the powder form. So two different crush rollers it will be rotating, and at the top side your metallic materials it will be introducing between crushers and it will be converting into finer particles. So as from the required number of passing of the crushers is required. Milling process. As shown from the figure, the milling process is commonly used for production of metallic powders. It is carried out by using equipment such as ball mill, impact mill, eddy mill, disc mill, vertex mill, etc. Milling and grinding process can easily be employed for brittle, tougher, malleable, ductile and hard metals to pulverize them. Generally, a large mass to be powdered first of all goes through the heavy crushing machines, then through the crushing rolls and finally through a ball mill to produce successively finer grades of the powders. If the requirement of the higher amount of powder, so this process is suitable. Condensation of the metal powders. This process can be applied in case of metals such as zinc, cadmium and manganese, which can be boiled and then vapors are condensed into the powder form. Generally, a rod of the metal say zinc is fed into the high temperature flame and vaporized droplets of the metal are then allowed to condense to a cool surface of materials to which they will be not adhere. This metal is not highly suitable for the large scale production of the powders. Characteristics of the metal powders. Most important characteristics of the metal powders are powder particle size, size distribution, particle shapes, purity, chemical compositions, flow characteristics, particle microstructures. So first, particle shapes. There are various shapes of the metal powders, namely spherical shape, sub-rounded, rounded, angular, subangular, flex, etc. So particle shape influences the packing and the flow characteristics of the powder. So best suitable choice for the shaping of the powder, that will be the round shape or you can say the spherical shape. Powder particle size and size distributions. Metal powders used into powder metallurgy usually vary in size from 20 to 200 microns. Particle size influence density, porosity of the compact, mold strength, permeability, flow and mixing characteristics, dimensional stability, etc. Particle size distribution is specified in terms of sieves analysis. It means the amount of powder passing through the 20 or 40 mesh sieves. So it will be the easiest method to separate out the different size particle size of the powders. Flow characteristics. Flow ability of the metal powders is mostly important in case where the molds have to be filled quickly. Metals powders with good flow characteristics fill the mold cavity uniformly. So it will be giving the ensurement regarding to the 100% filling of the mold cavity if it will be having a equal shape and size and its distribution. Chemical compositions. Chemical composition of the metallic powder implies the type and the percentage of the alloying elements and impurities. Basically that will be depends upon the requirement property of the materials, and it is usually determines the particle hardness, compressibility. The chemical composition of the powder can be determined by the chemical analysis methods. Particle microstructures. The particle microstructure reveals various phases, inclusions and the internal porosity. Apparent density. Apparent density is defined as the weight of loosely heated quantity of the powder necessity to fill a given die cavity completely. Mixing or blending of the metallic powders. So some of the advantages of the mixing and blending. So starting with the first one, to add lubricant to reduce the friction during the pressing operations. Powder particles get coated with the lubricants. This reduces the die wear and lowers the pressure required for the pressing. Second, to mix powder of different materials in order to obtain properties of the heat resistance, friction, heavy weight and hardness. Third, to obtain the uniform distribution of the particle size. Fourth, to add volatilizing agents to give a desired amount of porosity. Different powder in correct proportions are thoroughly mixed either wet or dry in a ball mill. In wet mixing, powder or solvent is used to obtain the better mixings. Moreover, wet mixing. First, reduce the dust, lessens explosion hazard which are present with some finely divided powders, and third, prevents the surface oxidations. So, proper blending and mixing of the powders are essential for uniformity of the finished products. However, over mixing should be avoided since it may be decrease particle size and work harden the particles. Compacting of the powder, or you can say the size and shaping of the powders. Compacting is a technique to converting loose powder into the compact accurately defined shape and sizes. So let's say from the figure at the initial stage, it will be the die which will be having a cavity as per my requirement shape, lower punch, upper punch, and in between it will be the powder. After applying the force from lower punch and upper punch in between the die, that loose powder it will be converting into proper shape and size. So it will be the simple compacting operations to converting your loose powder into the finished shape and size. So this is carried out at a room temperature in a die on a press machines. The press used for compacting may be either mechanically or hydraulically operated. The die consists of the cavity of the shape of the desired parts. Metal powder is poured in the die cavity and pressure is applied using the punches, which usually work from the top and bottom of the die as shown into the figure. Dies are usually made of the high grade steel, but sometimes carbide dies are also used for the long production runs. In the compacting process, the pressure applied should be uniform and applied simultaneously from the above and the below. The pressure applied should be high enough to produce the cold welding of the powders. Cold welding imparts a green strand which holds the part together and allows them to be handled. Roll pressing and extrusion methods are also to be utilized. So let's say it will be the roll pressing process. From the hopper it will be collection of the powder form, it will be passing through the different roller size. So with the application of high pressurized rollers, the powder it will be converting into the thin sheets. So it is used for production of the continuous strip sections using systems. There are two rollers of the appropriate size into which a regulated stream of the powder is guided so that the rolls are able to apply the necessary compacting pressure in a continuous sequence. Extrusion method. So here from the figure, it will be the container. One end it will be with the die, and die having a cross sectional area according to my requirement of the shape and size of the rod. So that extruded product, it will be coming from that die. The powder form, it will be filled into the container. With the application of ram, it will be providing the pressure onto the powder. So it will be moving from right side to left side. So according to the cross sectional area of the die, if it will be circular, triangular, rectangular, star shapes, whatever you want, just we have to make the die at that cross sectional area. So with the application of ram, it will be pushed and their extruded product will be collected from the second end of the die. So it is the method of the compacting does not give the such efficient control as that given by the pressing or even by the rolling. It is difficult to obtain the high density and some of the porosity is always left. The metal parts obtained after the compacting are not strong and dense. To improve this property, the parts should be sintered. So after the shape and sizing process or compacting process, further it will be the sintering process. So sintering and pre-sintering, it will be the basic two terminologies. Frequently, powder metallurgy used to make the parts from the materials that are very difficult to machine. When some machining is required on a such part, one goes for it pre-sintering before the actual sintering operations. Generally, pre-sintering operation is used for softening of the sintered component. So once you apply the sintering process in your components, which will be having a higher hardness, it will be present into the materials. Then if you want to carry out some secondary operations, so before that you have to performing the pre-sintering operations. So basic difference between sintering and pre-sintering, and that will be the heating range. So in the case of sintering process, heating of your component, it will be just below the melting point of higher constituent which will be present into the materials. In the case of pre-sintering, the heating temperature of your components onto the sintered product, so just below the sintering temperature of the materials or components. So after pre-sintering operations, compacted parts acquire sufficient strength to be handled and machined without the difficulties. Moreover, very little dimensional changes take place than in the final sintering temperature. For a pre-sintering, compacted parts are heated for the short time at a temperature considerably below the final sintering temperature. Pre-sintering is the necessary when holes are to be drilled in a hard to machine parts. Pre-sintering in addition remove the lubrications and binders added to the powders during the blended operations. Pre-sintering can be eliminated if no machining of the final product is required. So if we are proper controlling on to the shaping process, so you have removed the pre-sintering operation time as well as the cost. Sintering process. Sintering is done to achieve all the possible final strength and hardness needed into the finished products. Sintering consists of heating process metal in batch or continuous furnace to a temperature below the melting point of the major constituents, which we already discussed, in an inert or reducing atmosphere where the time, temperature, heating, cooling rate are automatically controlled. Most metals are sintered at the 70 to 80% of the melting temperature. Certain refractory materials may be sintered at the 90% of the melting points. So that will be depends upon the characteristics of the material and the chemical composition of the materials. So just you can see the transformation from point contact to line contact. So at the initial stage, figure number 1, particle bonding is initiated at the contact points. So if we are assuming that our each and every powder particles of the different metals, it will be in the shape of spheres, so it will be having a point contact. So after heating and pressing, that point contact, it will be converting into the next then it will be porous, and finally it will be into the grain boundaries and grain shafts, but it will be having some amount of porosity, it will be the present into the materials. So with the application of powder metallurgy process, the final product which will be having a porous materials, which will be having a higher hardness present into the material. Sintering is essential a process of bonding solid bodies by atomic forces. Bonding of the powder particles during the sintering can take place in any of the three ways: melting of the minor constituents, volume diffusions, although surface diffusions, evaporations and condensation also contribute to the bondings. And third, mechanical bonding or entrapping of the non-metallic particles in a metal matrix, which will be enhancing the properties. Hot isostatic pressing. Hot isostatic pressing involves applying pressure and temperature simultaneously so that molding and sintering of the powder take place at the same time. Said initially, first you have to make a finished shape and size, then after sintering process. So it will be the two different processes, but in the case of hot isostatic pressing, it will be the simultaneous process, heating as well as pressings. So the effect of time is important due to the viscous nature of the compact material, and the higher the temperature and shorter the time. So you should reduce the processing time and also making the good finished products. So dye materials for the isostatic pressing: steels, graphite and ceramics. High speed steel may be used for short time at 600 degrees centigrade and graphite for 700 to 3000 degrees centigrade. However, for graphite dyes are limited to pressure of 140 kilogram per centimeter square and also react with the metals to produce the carbides. Some of the advantages of the hot pressing process: reduction in gas contents and shrinkage effect, higher strength and hardness as compared to simpler process, higher density and sound compacts. Hot pressing breaks down any oxide films and exposes fresh surfaces. Some of the disadvantages of the hot pressing process: high cost of the die, because it will be higher temperature and higher pressure, so material having a capacity or ability to sustain the pressure as well as temperature to convert your finished products. Pressure takes a considerable time to complete. Application of the hot pressing. Hot pressing is used for production of very hard cemented carbide parts. Secondary operations. Some powder metals may be used in a sintered conditions, while in some other cases additional secondary operations have to be performed to get the desired surface finish or close tolerance as per the manufacturing standards. So annealing, repressing for greater density or closer dimensional control or dimensional accuracy. Machining is required. Sometimes polishing is also required. Rolling, forging, drawing, surface treatments to protect against the corrosion. In some cases, infiltration is needed to provide the increasing the strength, hardness, density obtained by the straight sintering. The procedures for plating powder metals parts are quite different from those used for wrought as well as or cast metal parts. In powder metal parts, porosity must be eliminated before the part is plated. After the porosity has been eliminated, regular plating procedure can be used. So a simple way, secondary operations which will be used after the sintering process if it will be required. The process of the powder metallurgy are quiet and clean. Article of the any intricate or complicated shape can be manufactured. So these all are the advantages of the powder metallurgy processes. The dimensional accuracy and surface finish obtainable are much better for many applications, and hence machining can be eliminated. Unlike casting, press, forming, machining, no material is being wasted as a scrap and the process make utilize full use of the raw materials. So you can use 100% utilization of the raw materials into finished products. So not any single process it will be following this theory. So it will be only possible in the case of powder metallurgy. So you should use the 100% raw material into finished products. Hard to process materials such as diamond can be converted into the usable components and tools through this process. High production rate can be easily achieved. So these all are the advantages. This process facilitates production of many such as parts which cannot be produced through any other methods such as sintered carbide and self-lubricated bearings. So in case of bearings or gears, it will be the only choice to make the components which will be having a self-lubricating characteristics, and that will be needed into the applications which will be increasing the life of the products and easily performance of the products. The components produced by this method are highly pure and bear longer lives. So it is possible to ensure the uniformity of the compositions since exact proportion of the constituent metal powders can be used. Simple shape parts can be made to size with 100 micron accuracy without any kind of waste. Porous part can be produced that could not be made in any other methodology. Structure and properties can be controlled more closely than in another fabrication processes. Highly qualified or skilled labor is not required in powder metallurgy process. Super hard cutting tool bits which are impossible to produce by any other manufacturing process, which can be easily manufacturing by the powder metallurgy process. Some of the limitations of the powder metallurgy process. So powder metallurgy process is not economical for the small scale production house, so which will be only feasible for the mass production. The cost of tools and die of the powder metallurgical setup is relatively high. The size of the products as compared to the casting is limited because of the requirement of the large presses and expensive tools which would be required for the compacting process or shaping process. Metal powders are expensive and in some cases it will be difficult to store without some deteriorations. It may be difficult sometimes to obtain the particular alloy powders. Articles made by the powder metallurgy in most cases do not have as good physical properties as wrought or cast irons. A completely deep structure cannot be produced through this process. The process is not found economical for the small scale productions. It is not easy to convert brass, bronze, which will be the copper alloys, and number of the steels into the powder form because that will be having a more ductility present into the materials. So more ductile materials it will be difficult to converting into powder form. Some of the applications of the powder metallurgy. The powder metallurgy process has provided a practical solution to problem to producing refractory metals which have now become the basic making of the heat resistance materials, cutting tools of extreme hardness present into the materials. Another very important and useful item for products made from powder metals is porous self-lubricating bearings. Porous products such as bearings and filters, tungsten carbide gauges, wire drawing dies, wire guides, stamping and blanking tools, stones, hammers, rock drilling, bits, etc. Refractory parts such as the component made out of the tungsten, tantalum and molybdenum are used into the electric bulbs, radio valves, oscillator valves, X-ray tubes in the form of the filaments, cathodes, anodes, control grids, electrical contact points, etc. Components used into the automotive parts assembly such as electrical contacts, crankshaft drive or camshaft sprockets, piston rings and rocket shaft buckets, door mechanisms, connecting rods. Products where the combined properties of the two metals or metals and non-metals are desirable, such as non-porous bearings, electric motor process, etc. Porous metal bearings made which are later impregnated with lubricants. Copper and graphite powders are used for manufacturing automobile parts and brushes. Let's see, you can see the different application of the powder metallurgy processes which will be used into the different machine components. Some of the gears, pinions or power transmitting, motion transmitting, which will be the requirement of the self lubricating characteristics of the materials, and it will be also some tools which will be higher amount of hardness is present. So thank you. If you like my channel, so subscribe, like and share. Mechanical Magic, Mechanical Learning Tutorials.